Hello everyone, we are here to give a working demonstration of our idea of helping the blind people. We are using TensorFlow model and OpenCV libraries in Python to detect real life objects in real time. The TensorFlow model which we are using has been trained for around 100 day-to-day real life objects using around 335,000 images. So you can just imagine how much data is required to build a model. So first of all, I would enter into my OpenCV environment. So for that I would have work on CV. It takes to my environment of OpenCV. So now I'm going to call my program prototype type py. So it's like a Python prototype.py. So here I have called the Python prototype.py. Actually, this TensorFlow takes a bit of time because it requires huge graphical work. So, and the program is running on an i3 processor, so it would take a bit of time to start the program. So let's see. Here, my webcam had started. So just wait a second before it get into full work. So here it is detecting me, right? And let me zoom it in a bit. Yeah. So now one by one I would pass object and let us see whether this detects the object in real time or not. So first of all I would pass let's say suppose scissors. Yeah, okay. So yeah, it is detecting scissors. The accuracy is varying with time to time because the object is moving and the camera is a bit slow. Webcam cameras are not that good as compared to the phone camera. Toothbrush, yeah, it is detecting toothbrush. Let's see whether it can detect both at the same time or not. Scissors. Okay. So, uh, hmm, yeah, it is detecting the both objects simultaneously. Okay, let's pass another object. No, it is not a toothbrush. Yeah, there can be error because let me just turn it around a bit. Should be glass or vase something. Uh, yeah, vase. That is an object similar to the vase. So let's pass another object, right? Yeah, cell phone. It detects cell phone with an accuracy of 99%. Yeah, percent. It is detecting my hand, right? Okay, let's pass another object. Yeah, hair dryer. Not detecting it. Let me make it more clear to the camera. Yeah, here it is detected hair dryer. Okay, again hair dryer. Yeah, it is detecting hair dryer. Okay, now let me turn the camera for the bottle. Yeah, it is detecting bottle, right? Okay, hot dog. No, it is not a hot dog. Let me turn the camera a bit toward my friend. Let's see whether it can detect. Yeah, it is detecting a person, laptop, couch, right? So the second phase of our idea is to recognize a text from a given image. So given an image, our program extracts the text from it. For this, we have used the PyTesseract and OpenCV library of the Python. What we can do is to pass an image from our camera and can read the text present in that image. So suppose that we have three images with text on it, scissors, toothbrush and bottle. Our program would read the text from this image and print the text in the terminal. So I have called my ocr.py and passed the image p1.png. That is toothbrush, and you can see here it has printed toothbrush in the terminal. Let's pass another image. Suppose I pass just a p2.png and the image, I think a bottle. It contains the text bottle. The image contains the text bottle, so it has printed the text bottle into the terminal. Let's pass another image of suppose we say a scissor. So our p3.png contains the image containing a text scissor, and scissor is printed on the terminal. Let's check it with another image. I have an image test1.png, which is screenshot of my browser. Sorry, it's not test1.png. It's, I suppose test1.jpeg. You can pass any format, jpeg, png, whatever. So let's wait because it contains a lot of text, so it's taking a bit of time as compared to the previous ones. So uh, so you can see we can use you can do many part of the machine learning using the Python. Okay, so we have used only Python and not any other language. So it's taking a bit of time to read, right? So just wait a second. Okay. So I think it is taking too much time. The whole picture is composed of a large amount of text. So just wait a minute. Yeah, here it is. You can see the screenshot here. It was actually the screenshot which first converted with the grayscale image, and it has printed the corresponding paragraph in the text in the terminal, right? So this is the second phase of our idea, that would extract text from a given image, and now we will pass this text to another phase. So now we proceed to the phase 3 part of our idea, that is, here we pass the text detected in the phase 2 to the phase 3, where our program converts the text into audio to the user. We pass the text to the program, and the text is read out to the blind people by the program. Here we have used the pypi132 library of the Python. So here I call my program python speak.py.
The detected object is toothbrush. The detected object is bottle. The detected object is scissor.
The pypi Win32 library is localized for a Windows environment. So accordingly, for the Android and iOS environment, we'll use their localized text-to-speech libraries.
Let me show you how our code works. Starting from the first phase of the idea, let's have a look at prototype.py. Here, initially, I have imported all the necessary libraries like TensorFlow, utils, OpenCV, PIL. Now, later on, we have got the models from our local directories. Okay, these models have been downloaded from the tensorflow.org. Okay, now we start our webcam using the OpenCV here, and the OpenCV captures images frame by frame, and our model works on these frames. The video's frames are passed as picture, and for each frame the model runs it program. The model selects the best match object from the pre-trained data and outputs it. We can train the model with more data and include more number of classes of objects. Now coming next to the OCR.py. Here we are performing the phase 2 of our idea, that is extracting text from the given image. Here we have used the same library PIL as we used in the first phase. The new library used here is the PyTesseract, ArgParse, and the OpenCV. So what we do is call the PyTesseract library and pass our image. The PyTesseract library, which is in turn a part of OpenCV, extract text found in an image and outputs the text found in the image in the terminal. Moving to the next and final phase, that is phase 3 of our idea, that is converting the text extracted in the phase 2 into audio. Here we have used the library win32com.client, which is a Python library. It is focused for Windows. Here we pass the text extracted from the phase 2, and the machine, that is a program, converts into an inbuilt voice.